choose recording. Okay, looks like it's working. All right, so I'm going to ask you guys a quick question here. If I wrote this fraction, what's another way of saying 2 over 2, Ms. Jennings?
1.
Yeah, it's 1, okay. What if it was something like, I don't know, 14 over 14? Somebody else, tell me what that would be equivalent to. Mr. Lee De La Rosa?
1.
Yeah, 1. So you guys understand that anything written as a fraction, if the numerator, which is what's on top, is the same as the denominator, it's also going to equal 1. Now, you guys won't see anything like this for a while, but what if if there was something like 1/3 over 1/3, and you'll see problems like that, not so much in 5th grade, but come junior high you will. That's also going to equal 1. And the same thing could be said for decimals. If I had 0.7 over 0.7, that's also going to equal 1. Who remembers what this line right here means? Anybody? I think I mentioned it early on in the year. Might have come across something. Yeah, Mr.
Over.
What's that?
Over.
Not over. I mean, you might say something like 2 over 3, but it doesn't mean over. Miss Adams?
Division?
Yeah, it's a division symbol. It means divided by. What's that? Oh, okay. So you could look at like 1/2. That's the same as 1 divided by 2. If I wrote 3/5, that's the same as 3 divided by 5. So that line means divided by, okay? Now, fractions generally are part of a whole of something. So if I wrote 1/2 and I drew a circle and I said, maybe show me, Mr. Lee De La Rosa, half the circle, you would draw a line and maybe color in half of it, okay? Or if I said, show me 2/3 of a circle, you might draw a circle and then divide it into thirds, okay? It's not perfect, but you guys get the idea. And if I said shade 2/3, you might go 1 and 2 and shade 2/3 of it. So fractions are almost always part of a whole. Another way to look at fractions is you could look at them on a number line. So if I said 3/4 and I ask you to put that on a number line, you could draw a line and then do 1, 2, 3, 4, okay? So I'm just going to put 0 over 4. I'm going to put 1 over 4, 2 over 4, 3 over 4, and then 4 over 4. So you can't erase this without erasing the whole line. Actually, what we'll do is this. Redraw that. There we go. So this would be 0, and this would be 1. You know that 4 over 4 is 1. And if I said, show me 3/4, well, you just put a dot right over 3/4. In this section, they talk a lot about estimating. So you're going to generally estimate a fraction as either a 0 or a half or 1. It's going to be one of those three, a 0, a half, or a 1. So if you were to estimate 3/4, do you think that's closer to a 0, a half, or a 1? Yeah.
It's even between 2, a half, and 1.
Yeah, it is. He's exactly right. It's right between what would be a half and what would be 1. And I think generally you would then just count it as 1. If it's right in between the two, you'd go above. But let's do another number line. How about if I said How about 3/7? Okay, so I'm going to draw my line. Actually, I'll do the vertical lines first. So 1, 2, 3, 4, 5, 6, 7. And I'm going to draw my line right here. Okay. And pull a stick. Mr. Fall, what would I put right here?
1.
Yeah, I could put a 1 right there, but if I was to draw the fraction, what would it look like?
7/7.
Yeah, nicely done, 7/7. Mr. Fall, I'm going to keep picking on you. What would I put right here?
0/7.
Yeah, 0/7, okay. Or you could just put a 0. And so everything else is between 0 and 1 on this number line, okay? So Mr. Button, where would I find 3/7?
On the 4th line.
Okay, so if you're counting where the 0 is, 1, 2, 3, 4, that's exactly right. So you could say really on the 3rd line, so that'd be 3/7. Okay. So Mr. Button, if I was to estimate 3/7, do you think it would be a 0, a half, or a 1?
Like a half.
Yeah, I think so. I think you're right. So on the number line that I drew, there's really not a place for a half, but it would be right about there. So that's pretty close to a half. So 3/7, if you were estimating, would be close to a half. Let's see here. So with this newfound information, I drew some number lines. All right. Look at 3/4. I'm going to pull a stick here. Miss Ugisa. So you can see where the 3/4 would be, right? Can you see it from back there? If not, get up and come closer to the screen. Do you see the 3/4 on this, honey?
Yes.
Okay, so it's right there. So my question to you is, and again, we're estimating, that's what this section's about. Do you think it would be a 0, a half, or a 1? Yeah, you would just call it a 1. Okay, good. Put up 20 points. Excuse me, Mr. Cosgrove, 2/7, the next one down. You see where it is? Okay. I'm going to put the dot right there. What do you think that would estimate to be? A half. So let's see here. Half would be right about there. So I think you're right. Yeah, nicely done. Put up 20 points. 9/10. Miss Noble. Can you see where the 9/10 would be? It's kind of small from way back there, but it's right there. So would you estimate that as being 0, 1/2, or 1?
1.
Yeah, it's obviously really close to 1, which is the same thing as 10/10. All right, a couple more. Put up 20 points. Mr. Moyers, 3/5. You can see where that would be? What's that? You don't know? Okay, so this is the one I'm looking at. Can you see it now? Okay, come up here and point it to me. Point it out. Yeah, good. Okay, so this is 3/5. So Mr. Moyers, is that closer to a half, a 0, a 1? I mean, what do you think? Yeah, I think it's closest to half, because if we were to draw this line in half, it'd be right about there. If this is, I'm sorry, whoops, if that would be 1 and this would be 0, the half would be right about there. So it's closest to a half. Good. And the last one, put up 20 points. Last one, Mr. Kamisa, 2/3. Do you see where it would be? Okay, it's right about there. What do you think? It'd be closer to a half, or 1, or 0?
1.
Yeah, so a half would be right about there. You still think it'd be closer to 1?
Like in between.
Yeah, I think, yeah, let's see here, 2/3, half.
Yeah, it's close to half. Yeah.
Yeah, I think it'd be closer to half, at least in my drawing there, it'd be closer to half, okay? All right, so let's look at the lessons here. So the first example, let's see here. It says Mr. Fish is welding together 2 copper. Yeah, go ahead. 2 copper pipes to repair a leak. He'll use the pipes that are shown. Is the new pipe closer to a half a foot or a foot long? And explain. So they went ahead in step 1 and they marked where 1/6 would be on the number line and 5/12 would be. And then it says a good estimate of 1/6 plus 5/12 is 0 plus a half or a half. And so it says since each is less than a half, it's reasonable that their sum would be less than 1. So I think that's a fair example. Let's just jump down here. Go ahead and cross out the convince me. I'm not worried about that. Let's look at the do you understand. I'm not going to worry about number 1. You could do number 2, and let's look at that for a moment. It says, if a fraction has a 1 in the numerator, okay, and so Miss Guerin, I'm going to draw a fraction, and I'm going to say x, I'm going to say y. Is the x or the y the numerator? The x is what's on top, that is the numerator. So they're saying in number 2 here, it says if a fraction has a 1 in the numerator, so I'm going to go ahead and do that. And then it says a number greater than 2 in the denominator. Okay, so I'll just put a 4 there. All right. Will the fraction be closer to 0 or 1/2? Explain. I want you guys to think about it. Okay? And would it be different if I did it like this? What's that? It wouldn't change anything? No? Let's take a look for a moment. I want you guys to think about this. I'm going to draw 1, 2, 3, 4, okay, and I'm going to represent 1/4. Okay, so this would be 0 over 4, 1 over 4, 2 over 4, 3 over 4, 4 over 4. 4 over 4 is 1, 0 over 4 would be 0. So 1/4 would be right there. I think we can all agree on that. Now I'm going to draw another line, except I'm going to represent 1/10. Okay? So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to draw all of them, but I'll do 0 over 10, and I'll do 10 over 10. And then you guys can see where 1/10 would be, 1/10. And I'll mark that one. Okay. So what was their question? It says, will the fraction be closer to 0, 1/2, or 1? Explain. Look at this first one here. Is it closer to 0, 1/2, which would be right here. This is the same as 1/2. Okay. Or 1. In the case of 1/4, which is the first one, the first example we thought about, it's right in between 0 and 1/2. You guys see that? In the case of 1/10, look at that one. What's it closer to? Obviously 0. So it does matter. So anyways, looks like number 2 is done for you since we just talked about it. All right, let's look at 3 and 4. So 3 and 4 use the number line to tell if each fraction is closer to 0, 1/2, or 1. All right? You guys can do that. I think that's pretty self-explanatory. Number 5, same thing. So let's do number 5 together. So I'm looking at 5A, and I'm going to mark 7/8. So 7/8 would be right about there. So it's closest to 1. And then 5/12, well, 6/12 would be 1/2. So 5/12, I'll use a different color. How about blue? So 5/12 was not quite 1/2, but right about there. That's closest to 1/2. Okay. So then it says to estimate, and you guys make sure you write this down because you got several problems like this. It says to estimate the difference between 7/8 minus 1/2. So I decided that the 7/8 was 1. And then the 5/12 was pretty close to 1/2 because I'm estimating. And so then the question is what is 1 subtract 1/2? Not a negative 1/2, just 1/2. Yeah. 1 subtracting 1/2 is 1/2. Okay? So that's the answer to number 5. So up above, 3 and 4 are just like number 5, what I just did for you guys. Okay? So how about, let's look at number 11 for a moment. So it's 37 over 40. Okay? We're estimating. Is 37 over 40, if I was to draw a line, here's 0, here's 1/2, and here's 1. Where would 37 over 40 be? Miss Gage, what do you think? Tell me, I'm going to start right here, and I'm going to start going across. And when you think I'm pretty close to where 37 over 40 would be, you tell me to stop. Yep. Okay, pretty close. I think it'd be a little bit further because it'd be pretty close to the end because it's almost a 40, but not quite. Okay? So 37 over 40, I think it'd be fair to say that would be an approximately 1. Okay? So again, this is number 11 we're looking at. And then we're subtracting 26 over 50. Okay, so I'm going to draw a line here. And I'm going to put a 0 there. I'm going to put 1/2 there and a 1 there. So 26 over 50. Mr. Eberhardt, what's half of 50? 25. All right, so you tell me when to stop when you think I'm getting pretty close to what 26 over 50 would be. Okay. Yeah, it would be just past a half. So 26 over 50, if we were estimating, I could say is 1/2. Now let's go back to problem number 11. What's it saying? 37 over 40, subtracting 26 over 50. So we could rewrite it as 1 subtract 1/2, which was just like the one that we had. What's the answer? 1/2. Okay? Anybody confused about anything I've explained so far? Not yet. Not yet, they say. Not yet. Okay, all right. Let's look at number 12 here. How are we doing on time? Let's see here. Name two fractions that are closer to 1 than to 1/2. You could do that. Name two fractions that are closer to 1/2 than to 0. And two fractions closer to 0 than to a... Yeah, you guys could do that. Number 13, how could you estimate whether 27 over 50 is closer to 1/2 or 1 without using a number line? So 27 over 50, without using a number line, how could you estimate that that is closer to 1/2 as opposed to 1 without using a number line? Yeah, question. Question or comment?
It was for the question.
Yeah.
Can I answer?
Yeah, go ahead.
25 is half of 50, so 27 is closer to half than it is to 1.
Perfect. I like the way you said that so much, I wrote it down. 25 is half of 50, so 27 over 50 is closer to 1/2. And he answered that without using a number line. Number 14, Katie made a bag of trail mix with half a cup of raisins, 3/5 cup of banana chips. How many like banana chips? Raise your hand.
What?
Who likes banana chips? Not many, yeah. And 3/8 cups of peanuts. About how much trail mix did Katie make? So you're going to have to estimate 1/2. Well, 1/2, that equals a half. That's an easy to estimate. 3/5, you're going to have to estimate that one. And then 3/8, you're going to have to estimate that one. And then you're going to add up all three of them. And that'll give you an approximate. Number 15. Annual mug race is the longest river sailboat race in the world. What state is that?
Florida.
Who's doing Florida? There you go. So you have a tidbit, a bit of information on Florida that you might not have had otherwise. Good thing you were here today. All right, the event is run along the St. Johns River, 310 miles long. About how many times as long as the race is the river? Okay, so they give you the information of the length of the race and the length of the river, so you guys could do that. Finally, 16, part A, Steve is making breakfast. The recipes call for 7/8, 3/4. He only has 2 cups of milk. Does he have enough to make his, yeah, you guys could do that one. Yeah, I'm not worried about part B, scratch that out. So just do part A. Okay. All right, everybody say goodbye. Oh, wow, that was 24